Even if you do, I have good lawyers.
Okay. So let's see.
Voice right issues.
Let's see. Question 1. Okay. So
Welcome back to my channel.
remember to subscribe.
Yeah, we have a new guest, right?
Yeah.
Even his guest specialist.
So okay, question number 1. We have this code. So this is the implementation of the lock function, and this is the implementation of the unlock function. So you have 2 threads, I and J, and they'll be calling lock and unlock to go into critical sections arbitrarily. So the first case, is this mutually exclusive or not? So in this case, to answer the question, we can prove by contradiction that it is mutually exclusive.
Yeah.
Oh gosh, I didn't need this table.
It's okay.
Forget the table. So assume that there is no mutual exclusion. So first, well, the answer is mutex is yes. So to prove it, assume mutex is no. So if mutually exclusion is false, then at some point, threads I and J will be in the critical sections together at the same time. So now you have to ask yourself, which thread entered the critical section last? Or which thread called the first line in the lock function last? So if thread I called it last, then that would mean that J went first. So J would call flag J and set that to true. And then if I comes along later and sets flag I equal to true, then flag I will not be able to go past this while statement because flag J would have been set to true previously. So that's the contradiction, that I would get stuck here. It would never end up in the critical section. So that proves that mutual exclusion is satisfied. Second case is liveness property. And liveness is satisfied. Wait.
Second case is it is liveness.
Let me see. I need to see the answers. Liveness is not satisfied.
Yeah, yes. In this case, liveness is not satisfied.
Liveness is not satisfied because if thread I does L1 and sets flag I to true, then thread J goes to L1 as well. Context switch to thread J. Flag J is set to true. Now both flags are true, and for any thread, they will both be blocked waiting for the while loop.
Yeah.
So it's not liveness. Is it fair? Well, there's the logical expression. If liveness is not satisfied,
Then it's not fair.
then it's not fair. We know it's not fair. And the reason is because liveness is, the definition of liveness is for any thread that is waiting to go into the critical section at this while statement, then as long as some other thread is able to get into the critical section, then liveness is satisfied. But fairness is more specific, because in order for fairness to be satisfied, every thread that wants to go into the critical section, it must be that same thread that ends up later in there.
Oh.
So if you have fairness, you know you have liveness. But the other way around is not true. If you have liveness, it doesn't mean you have fairness. You still have to check fairness separately in that case. So question 2 now. So is it mutually exclusive? Yes.
Yes.
Because in this scenario, we have the flags, I and J, but we also have this turn variable, which is initialized to thread I, but notice that the turn is never changed in any of the functions, so turn is permanently set to I. So if thread I calls lock, then this comparison for turn equals I is always going to be true, because I is always equal to itself. So if you have true or something,
That is true.
it's always going to be true.
And it's always going to be waiting.
So it's always going to be waiting. So I will never be able to go into the critical section under any circumstance. So if I is never able to go into the critical section, that means that there'll only be 1 or 0 threads in the critical section. So we don't have 2 threads in the same time. So we have mutex. And now the liveness property. Liveness is a no, because if I wants to go into the critical section, it will be stuck permanently, as we said. And if J never wants to go in, then J will never be in the critical section. So that means we have a thread that's waiting, and there's no finite amount of time where another thread will be in critical section. And so likewise, the same argument could be applied to show that fairness is not valid, because I is waiting to go in, but I itself will never be in, so it's not fair.
Nice.
Yeah. Question 3. We have the 2 flags again and the turn variable again.
But now and instead of or.
Yeah, and in this case we have and instead of or. So just like in the last problem, turn never changes. So turn is always initialized to I. So to check for a mutual exclusion, in this case there's no mutual exclusion. And the way we prove that is by providing one example that violates mutual exclusion property. So one example that would violate it would be if thread I runs L1 and L2, so flag I gets set to true. And then in this case, we have true and false. So I goes into the critical section because this whole expression evaluates to false. And then when J comes, you have flag J set to true, and turn equals J instead of I, because this is the J thread, and flag of I. So since turn is still I, you have whether I is equal to J. That's false, and that's always going to be false. So J is always going to go through. So I is already in the critical section from before, and now J, we find out that J can always go no matter what. So J can go into the critical section too. So there we have 2 threads at the same time.
So you have the...
that violates the mutual exclusion property. And now note that liveness is true, because since J is allowed to go in whenever it wants, since this condition will always evaluate to false, and then false in anything will always be false, J can go whenever it wants, so it'll never be blocked. So there's always going to be aliveness, because no matter what I does, at least J will be able to go into a critical section. But note that there's no fairness here, because if I is waiting for
and J is going to...
and J goes through, J could lock again before I gets a chance to go into the critical section.
So I will be always
waiting. Yeah,
this
because
was like
J
the
could...
problem with the kind of timing that
with the
J
timing.
could be always like a little bit faster. And
Yeah. Okay.
That's it. Nice.
guys, thanks for watching.